Factorial notation. Objective. By the end of this lesson, you should be able to evaluate factorial directly using a calculator or even using Pascal's triangle. So first, what is a factorial? Well, it's a non-negative number. This is a product of all the numbers beneath it. So right here, you say n factorial. We use a notation of a exclamation point. You just go n times the number below that, n minus 1 times the number below that, n minus 2 times 3 times 2 times 1. So for example, 5 factorial is just going to be 5 times 4 times 3 times 2 times 1. That's all it is. By definition, we say 0 factorial equals 1. There actually is a reason for it, but because factorials are really tied to probability, but we'll talk about that more when we get to probability. For now, I want you just to know that when you have a factorial, a number, you just multiply all the numbers beneath it, below it. So let's evaluate 4 factorial. So that's going to be 4 times 3 times 2 times 1, which is what? 12 times 2, so 24. So 4 factorial is 24. I could do the same thing here with 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. I want to point something out. If you look at right here, right, 4 times 3 times 2 times 1, that's the same thing as just 4 factorial. So really, this is just 6 times 5 times 4 factorial. And we know what 4 factorial is. That is 24. This is 30. So it's 24 times 30. So 12, 6. So 720. And that's actually a key thing about factorials. You can stop anywhere you want and just rewrite it as something times something factorial. Because this right here is 5 factorial, right? 5 times 4 times 3 times 1. So really 6 factorial you could write as 6 times 5 factorial. Or you could write as 6 factorial as 6 times 5 times 4 factorial. And so on and so on. 6 times 5 times 4 times 3 factorial. You can always, anytime you do a factorial, you can always just stop and write the rest of the factorial. So for example, if I wanted to write 9 factorial, I could write this as like 9 times 8 times 7 factorial. Right? I could stop at 7. Or I could keep on going lower. You can stop anywhere you want, put a factorial, now stop it. Why do I bring that up? Because that's how we simplify the next set. So right here I have 8 factorial over 6 factorial. The trick to doing this is you get the bigger number and break it and rewrite it. Rewrite larger factorial. So I'm going to have 8 times 7 times 6, and I'm going to stop at 6 because these would cancel out until you reach the smaller factorial. So I'll stop there, and then I'll have a 6 factorial on the bottom. These two will cancel out, and I just get 8 times 7, which is 56. I hope. 8 times 7 is my worst multiplication. So you can see right here with the 120 over 119, that looks scary, but we just go, wait, this is a bigger one. Let's break down. So 120 times 119, and I'll stop there, because the bottom one's 119 factorial. These cancel, I just get 120. It works the same way when there's just variables, n plus 1 over n minus 1. Which one's the bigger one? N plus 1's the bigger one. So break that down. So I have n plus 1 times 1 right beneath it. What's 1 less n plus 1? Well, if you subtract this by 1, you just get n. Still not matching, so you go 1 lower. What's 1 lower than n plus 1? N minus 1. I'm going to have to squeeze this in. N minus 1 factorial. And I'll stop there. Again, you can stop anywhere you want. I'll stop there because that matches n minus 1 on the bottom. Sorry for the bad. I just ran out of space. These cancel, and you're left with n times n minus plus 1. Or if you want to be a pro about it, n squared plus n. So that's what I do when there's variables. And we'll do a couple more in a second. Let's do this one. There's 2 things in the denominator. Well, we're going to do the same idea. We're going to break down until we get the smaller factorial. So 8 times 7 times 6 factorial. I'm going to leave 6 factorial alone. So because that's going to cancel. What we do with the 2 factorials, we expand that one. Because that's not going to cancel anything, so we're going to expand that. So that's going to be 2 times 1. Right, so let's expand 2 factorial would be 2 times 1. And then we simplify. 6 factorials cancel. We have 8 times 7 over 2. And you could 56 divided by 2, or you could reduce beforehand. 1 and 4. 4 times 7 is 28. That's how I do that one. We're going to do more of that in a second. N plus 1 over n plus 3 factorial. Again, we're going to get the bigger one. In this case, the bigger one's in the denominator. We'll just branch it out. So n plus 3 times the one beneath that, which is n plus 2, times the one beneath that, which is n plus 1. And there I could stop because that matches n plus 1 on top, n plus 1 factorial on top. These would cancel. And you get 1 over, don't forget when you cancel something for the numerator, it's still 1 there, n plus 3 times n plus 2. That's my answer. Over here, we'll do the same thing now. The bigger one is the one down here because it's plus 2. So how do you break that out? Well, write it first. Times the one beneath it. 1 less than that would be, subtract 1 would be 2m plus 1. 1 beneath that would be 2m, just 2m. Right, so subtract 1, you get 2m plus 1. Subtract 1, you just get 2m. That's what cancels with 2m on top. End up with 1 over 2m plus 2 times 2m plus 1. So that's how you simplify basic factorials. Now let's move on to the binomial coefficient. So we'll talk about this a little bit more in stats, the further stats we're going to do. But for now, you need to know that this is another way of writing a factorial. So it's a specific formula called the binomial coefficient. There's lots of ways to write it. You can see like this is probably where you can see the most. That's how I'm going to write it. You might see this, NCR. You might see CNR. But this is one we're going to use the most, and there's a formula to it, which I believe is in your formula sheet. So N over R, binomial coefficient. So we call it, a lot of times we say this is NCR. That's the way we read that. Is N factorial over R factorial, right, the bottom one, and then you subtract the 2, N minus R factorial. So let's evaluate one of these. So the way we write it is you write the top number, factorial. You write the bottom one, factorial. Then you subtract the 2. So 3 minus 1 is 2 factorial. And then we're going to simplify this, just like we did over here. The exact same concept. So I'm going to write out the bigger one, which is 3. You're going to expand it until you get to the bigger one on the bottom, which is 2 factorial. So I'll stop there. On the bottom, you're going to leave the bigger one alone because that can cancel out. And you're going to expand the smaller one. Well, here we just have 1. And then what happens, these cancel out, and you just get 3. Let's do it again, it's a little more interesting, 4, 2. So 4 factorial on top. On the bottom, it's going to be the bottom one. And then you subtract the 2. 4 minus 2 is also 2 factorial. So you have to expand the top one. So that's going to be 4 times 3 times 2 factorial. Right, you keep on expanding until you get one that's going to cancel. Then reduce these cancel out. 2 factorial does not, so we're going to expand that. And then you just reduce. This is 12 divided by 2, which is 6. We can keep on going. We got 7, 3 here. So I'm going to write that as 7 times, oops, sorry. I should rewrite it first. I'm going to get ahead of myself. 7 times 7, I'm getting ahead of myself again. 7 factorial is what I should write. Over 3 factorial. Right, so you see the formula 7 factorial over 3 factorial, and then subtract the 2. 7 minus 3 is 4 factorial. Now I could expand the top. So the top's going to be 7 times 6 times 5 times 4. I'll stop at 4 because that's going to cancel it down there. Remember, the 4 is going to cancel, the 3 is not, so we're going to expand that one. 3 is 3 times 2 times 1. Right, so 4 was cancel. And then I'll just rewrite the rest. So 7 times 6 times 4 over 3 times 2 times 1. If you can see, 6 and then 3 and 2 are also 6, so these cancel. And so it's 7 times 5 over 1. 35. Now sometimes these get big. 10, 4, that's going to be what? 10 factorial over 4 factorial, 6 factorial. We can expand it, but I forgot. I was going to show you how to do it on a calculator also. So here's my calculator. If I want to do a factorial in the calculator, a couple of things. I probably should go to the top first. How do I do like 4 factorial in the calculator? Well, you want to go to math. Actually, you want to type in 4 first, I believe, most of the time. And then you want to go to math. And we want to go over the probability. So I'm going to hit left. And then you can see the factorial right there. Select it, 24. Right? Now, if you're going to do something like this on the calculator, you're going to have to use parentheses on the bottom to make sure they're together, or you can use a fraction fraction button. But when we get to there is the way to do this. Now remember I said this is NCR. That pops up in our calculator. So let's do 10 4 on our calculator using NCR. So most of the time you have to type the first number in. So the top one, 10. Then I'm going to go to math, go back to probability, and there's the NCR right there. Like that. So 10 NCR, and then the second number, 4. The bigger number should always go first. It's a general trick. And you get 210. So, sorry, this is 210. So we solved it with the calculator, we solved it by hand, and there's a third way to solve. So we solved it with the calculator, we solved it by hand. There's a third way to solve binomial coefficient, and that's using Pascal's triangle. So the key to Pascal's triangle, well, again, so first of all, it only works with binomial coefficients. So it's not going to do factorials for you, which, I mean, this is multiplying. It's to do stuff like this. So anytime you have binomial coefficients, which is going to be important for us, it's going to use to solve that. So the key to it is how to build it. To build Pascal's triangle, we start with the 1. And then we go put a 1 on each side. So it's going to be like this, 1 and 1. That's the next row. The next row, we start with the 1. And then we add these two terms. And we get a 2. And then we end with the 1. Right? So we're always going to bring down 1s on the side. So 1, 1 on the side, 1, 2, 1. So we go again. 1, add these together, we get 3. Add these together, we get 3. And then a 1. So, right, start with the 1, add these together, add these together, add these together. Those together should be 6. And then a 1 at the side. And keep on going. I'm going to go down row 7 is my goal. So 1, 5, 10, 10, 5, and a 1. Again, so 2 more rows. 1, 6, 15, 20, 15, 6, and 1. And then we go one more time. Actually, I want a little bit more space. So let's make this a little bit smaller. There we go. So 1, 7, 21, 35, 35, 21, 7, and 1. And I got a little sloppy at the end, but that's how you build a Pascal triangle. And you keep on going for as long as you want. Now the reason I stopped at 7 is because you can see here my binomial problem goes up to 7. So this is Pascal's triangle, right? Start with the 1 on each side, 1 on each side, add the middle 2 up, 2, and then just keep on going down like that. Now the key of Pascal's triangle is how do you name each row? So the first non 1 number you see, that's what row it is. So this is row 3, this is row 2, and so on. This would be row 7. Up here, row 1, right? This is row 2, so the one above it's row 1. And the one above that is row 0. Just like that. Okay, so how do we use it to evaluate Pascal's triangle? So let's look at 3, 1 right here. So to evaluate 3, 1, we need row 3. So here's row 3. Now just to show you, I'm going to rewrite it up here so we have some context. So here's my row 3. The way this works is like this. The very first term is the binomial coefficient of 3, 0. Then you go 3, 1, 3, 2, and then 3, 3. So like that. So it goes for all of these. So 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. I want 3, 1. So my answer should be 3. Now we did this by hand earlier, so we could see if we check our work. Right? 3, 1, we got 3. So there we go. So the next one, 4, 2. 4, 2 is right here. Right here's row 4. We're going to go to the second one. So this will show you. This is 4, 0, 4, 1, 4, 2, 4, 3, and then 4, 4. So I want 4, 2, which is right here. 4, 0, 4, 1, 4, 2. So it's 6. Check our work. We did by hand over there. It was 6. Okay, and let's talk about 7, 3. Right, so it's going to be the same thing. So 7, 3 should be row 7. So 7, 0, 7, 1, 7, 2, 7, 3, 35. Right, and again, we did do that one by hand. We got 35. So that's how you do Pascal triangle. Now, what's not great about Pascal triangle, like 10, 4 I could do by hand. It's a little big, but I could do it by hand. It's going to take you forever to do this way. Good news, if you do it once, you can use it for lots of things. now that we know Pascal's triangle, just by looking at it, there's actually a couple hints, a couple shortcuts that Pascal's triangle gives us. So let's talk about those. Let's talk about the hints. First thing, if you notice the very first term, 4, 0, if I did it down here, right, 7, 0, 7, 1, 7, 2, 3, 7, 4, 7, 5, 21, 7, 6, 7, 7. If you notice the very first term, 7, 0, 3, 0, 4, 0, it's always 1. So anytime you see an n over 0, no matter what number it is, it's automatically going to be 1. Another thing, the last term, 4, 4, 3, 3, 7, 7. Anytime the number over itself, it's the last term, that's also 1. So those two things equal 1. So that's the first hint. So anytime you have the first term or the last term, which would be a number over 0 or a number over itself, that's automatically 1. How about this one? If you notice the second term here, 7, 1, 4, 1, this would be 6, 1. If there's a 1 on the bottom, it's automatically the number that's on top. So right, 3, 1, automatically 3. So if you have n over 1, it's automatically n. And that happens another time too. If you look at here, 4, 3 is automatically 4. 7, 6 is automatically 7. If the top number, the bottom number is 1 smaller than the top number, it's automatically the top number. 3, 2 is 3. So if you have this, n over n minus 1, then it's automatically n. And that's about it. There's no other rules. Well, we can get on here. So let's do a couple examples. Let's say if I give you 9, 8. If I give you 10, 10. And then we'll do one normal one. Let's do 5, 3. Okay, so 9, 8. So that one, you don't have to look at it. I don't want to go in row 9, but I knew the shortcuts. If these are 1 away from each other, then it's just the top number. So this will just be 9. If they're the same, it's automatically 1. Right, using the shortcuts. This one is not a shortcut. They're not 1 away from each other, none of that. So how do I do 5, 3? I have to look at my table here. This would be 5, 0, 5, 1, 5, 2, 5, 3. So it's just going to be 10. And that's how you use Pascal's triangle. And that's the lesson.